Good afternoon, Kumaran.
Good
You're able to
afternoon,
hear
sir.
me, no? Yeah,
Yes,
yeah,
sir.
yeah.
I can hear.
Now, can you tell who all from your group have joined? I'll make them all co-host.
Yes.
Yes, sir. One is
Sushant,
myself,
Hi.
Kumaran.
okay. Yeah,
Yes,
Sushant.
Sushant.
Yeah.
Yeah,
Yes,
Sushant.
sir. Sushant here.
and Suman.
Okay. Oh, Suman is also here. Okay.
Yeah, you may join.
Yeah. Okay. So now I have made Sushant and Kumaran. Then who else is here? Suman is yet to join, no?
Yeah, he said to join, not yet join.
Yes,
Okay.
yet to join, sir.
Will Joby be joining? Joby?
Yes, sir. Yes, sir.
Okay,
Yes.
okay. So once he joins, I'll make him also the co-host if required. Okay, so we have actually 200 registered participants. The last session got completed a bit late. It was almost 2 when we left from here. So that is why there can be, but we will start the session at 2:30 itself. There is no change in
Okay.
that. Okay.
Okay.
No problem.
By that time people will join, no problem.
Yeah.
And
Yes.
afternoon there is only one session, so there is no problem as such.
Okay, sir.
Okay, no one will be waiting after your talk, so there is no issue like that.
Okay. Understood, sir.
Then we will give you the presentation privilege a little later after introducing you. So that is the convention.
Yeah. Yeah.
Okay.
Yeah, sure.
Yeah. Meanwhile, if you want to check, we can give, and then if it is required.
Yes,
Otherwise-
sir. So, sir, can you just
Yeah. Then I'll give you the.
help me?
Yeah. Sure. Whom should I give? Sushant or
Sushant? Sushant, sir.
Sushant? Okay. Yeah. So I have made you now the presenter. Just a
So-
second. Yeah, I think just a second. Yeah. Now you are the presenter. You can try
Okay,
showing
just
the.
a moment. I'll just
Yeah.
let me know when my screen is visible, sir.
Yeah. Yes. It is visible. It is visible.
It is visible, right?
Yeah. Perfect. No issues.
I'll just stop sharing it now.
Yeah.
My voice
So-
is clear, right? Sir?
Yeah, voice
My
is also clear. Voice is also
Yeah.
clear.
Great.
So Kumaran, would you like to? Are you at the same place? You must be at different places, right?
No, sir, different place. I think better.
Okay.
I can also try.
Yeah. So then, shall I give the privilege now to Kumaran? Sushant, is it
Yes.
okay?
Yes,
Yeah.
sir.
Okay.
Yes, sir, I got that. So
Yeah. Yes.
let me know, sir, once you can able to see the screen.
Yeah. Yes. And it is the
Yes,
same slide, no?
Kumaran.
Yeah.
Yes, sir, same, similar kind of slide.
Similar slide. Yeah. Yes.
Similar kind of
So it is
So-
visible and your voice is also clear. No problem.
Yeah, sir. Right.
So
Great, sir.
as such, everything is perfect.
Yes, sir.
Okay. So now, Abhinaya, who will load that present title slide, etc.?
The Saji, sir. I'll make
Saji.
him. Yes, sir.
Just make him. Will you be able to make him?
Yeah,
I'll
yes,
make him
sir.
a co-host.
Yes, sir. I've made him as a presenter.
Oh, okay. Then I'll
Okay.
make him co-host also.
Okay, sir.
Okay. And Saji is going to introduce the speakers also, right?
Bindu ma'am will introduce, sir.
Oh, Bindu will. Okay, fine.
Sir, Kumaran here. Sir,
Ashwini, I am making you also the co-host. Then anybody else from our team here?
That's all, sir. Nobody
That's
else will
all.
join. Yes.
Okay, fine. Sorry. First, Kumaran will present, no? After that, it is Sushant. That is how you have decided, right? Or is it the other way? Sushant or Kumaran? Yeah. What is the order in which you are presenting? Either is
Sushant, if
okay
you
for
are-
us. From our side, there is no problem.
I can start first, sir. No problem.
So, okay, Sushant will start first, and then
Sushant,
yeah,
yes.
Kumaran. Yeah.
Yes.
Yeah,
sir.
in fact, being co-host, you have the privilege of making another person presenter. So you, from your end itself, you can do that. At any point, if you want to give the privilege to someone else, you can do that. That is why we have made
Okay.
you co-host also. Okay.
Okay.
Yes,
Okay.
sir. Perfect. Perfect.
Okay. Or if in case if you require our help, we are also there. No problem. We also can do that.
So how do I make Kumaran as a presenter? If you can help me with
Yeah,
that.
just you can. What you need to do is just click on his name. Automatically, he will become the. There will be a blue sort of ball coming there. You just
Make
click
this
there.
participant as presenter.
Yeah, that is it. That is
Okay.
it.
So
Okay.
got it. I'll do that at end of my session, sir.
Okay.
Yeah.
Okay. So 47 have joined. I think let people join. We will stick to the time, stick to the schedule.
Yes, sir.
Okay. So okay. So good afternoon and welcome back. We are into the 12th session of our FDP. And today we have in the session two presenters, and both from PerkinElmer. So in fact, we our lab has a long association with PerkinElmer. We use many of their instruments. In fact, most of our sophisticated instruments are PerkinElmer instruments. Other instruments are in fact few in number. Most of our good instruments are all from PerkinElmer. So whenever we call them for some help, they readily agree. So this time also, without any hesitation, they have agreed to present in our session. And as I said, there will be two presentations. One will be on something related to microplastics, its detection, etc. And the other will be on techniques for water quality analysis, the sophisticated techniques for water quality analysis. So being resource persons from the industry, I request all the participants to make full use of their expertise, because on the working of the instrument, that side, they are real experts. And on the application side also, so you can, you also in your lab must be having some of these instruments, or maybe you may have plans of buying new instruments. So you can clear your doubts with the resource persons. So with these words, let me invite Bindu AG to present to introduce the resource persons. Bindu, please.
Thank you, sir. So good afternoon all. PerkinElmer is an American global corporation focused in the business area of diagnostics, life sciences.
Bindu, your voice is a little feeble.
So,
a little feeble. Can you be a little more louder? It is a bit feeble.
I will check. Hello?
Yeah,
Hello?
yes. Carry on.
Okay?
Still it is feeble, but that is all right. You continue.
Okay.
Little loud, yeah.
PerkinElmer is an American global corporation focused in the business area of diagnostics, life sciences research, food, environmental and industrial testing. Its capabilities include detection, imaging, informatics, and service. PerkinElmer produces analytical instruments, genetic testing and diagnostic tools, medical imaging components, software instruments, and consumables for multiple end markets. So their focus areas, to list a few: cellular research, clinical genetics and diagnostics, drug discovery, environmental analysis, air, water and soil testing and analysis, food safety, then forensic analysis, hydrocarbon processing, imaging, lighting, sensors, pharmaceutical development, analysis of uranium and thorium, etc. So today we have two experts from Perkin-Elmer with us. So Mr. Sushant Jadav, Senior Field Application Specialist based at Mumbai, and Mr. Kumaran N, Senior Field Application Specialist based at Bengaluru. So about Sushant Jadav. So Mr. Sushant Jadav has completed his master's in analytical chemistry and he has more than 12 years of industrial experience in analytical solutions. He is currently associated with Perkin-Elmer as Senior Field Application Specialist. So in this capacity, he provides analytical solutions in the fields of material characterization with products in molecular spectrometry, thermal techniques, and hybridization. He has excellent reputation for product support by resolving problems, improving customer satisfaction, and deriving overall operational improvements. Then about Mr. Kumaran N, Senior Field Scientist, Application Specialist based at Bengaluru. Then about few words about Mr. Kumaran. So Kumaran has completed his Masters of Science in Chemistry, so from FTIR University, Salem. He has currently working Perkin-Elmer after around 4 years, and prior to that 6 years he worked in various reputed firms in the field of environmental engineering, equipment, tools, food, etc. Then, so he has worked with on atomic absorption spectrometry, ICPOES and ICPMS analytical platforms, and supports operational training and critical application to the customers. So today, the first session starts with Mr. Sushant. So he will discuss about FTIR microscopy, imaging solution for the microplastic analysis in different water types. After that, Mr. Kumaran will speak us about heavy metal analysis, especially ICPOES and ICPMS. So on behalf of participants and coordinators, I welcome you people from Perkin-Elmer. Thank you, sir.
So thank you, Bindu. So Sushant, it is over to you, please.
Yes, George, sir. Thank you very much. Is my voice audible, sir? Just to check.
It is audible. It is audible.
Sushant, it is audible, right?
Yeah.
So yeah, thank you, sir. So good afternoon, everyone. Hope you all are safe and healthy. I'm Sushant Jadav. So firstly, I would like to thank NIT Calicut team to give this opportunity to Perkin-Elmer for presenting the recent developments or the emerging technologies for sustainable environmental management, for which my colleague Mr. Kumaran will be sharing his insights on one-stop solution for heavy metal analysis in environmental samples by atomic absorption, ICPMS. And I will be briefing about IR microscopy and imaging solutions for microplastics analysis in different types of water, be it fresh water, ocean, sea water, as well as drinking water. So to start with, the history of Perkin-Elmer. In the year 1937, Sir Richard Perkin and Sir Charles Elmer founded an optical shop of Perkin-Elmer, and the first IR spectrometer model 12 was launched in 1944. So if you see, almost every decade, Perkin-Elmer has always been over the edge for understanding the market's requirements and the technology advancements. Like the first commercial microscope was launched way back in 1954. The first low-cost Fourier transform, FTIR, was launched around 1987. Perkin-Elmer was the first company to gain ISO 9001 certification. Then in 2001, the first rapid chemical imaging system was launched. In 2006, Perkin-Elmer introduced the ATAR imaging system. A dual range mid-IR near-IR systems with automated range changing was launched. In 2011, a low maintenance and a portable FTIR, which is Spectrum 2, was launched for everyday analysis. So this was just to give you a glimpse about Perkin-Elmer's continuous innovative approach to cater the current and the upcoming or the recent market needs. So here is what I plan to cover during this webinar. Firstly, I'd like to give some background about the problems of plastics and microplastics pollution. Then I'll show how the infrared spectroscopy is an ideal technique for measuring these microplastics particles. I'll then go to a complete example of extracting and analyzing microbeads present in the cosmetic formulation. I'll discuss in detail about what exactly are microbeads. Finally, I'll show you two different independent case studies of the infrared imaging to applied for microplastics in European waterways and sewage treatment plants, including a procedure for the sample cleanup prior to the analysis. So let's start. Infrared microspectrometry or IR microscopy is an analytical tool that characterizes both the chemistry and the physical structure of materials. The method combines two separate approaches. One is vibrational spectroscopy and the other one is a light microscopy for elucidating. Hello. Excuse me, sir.
There was an error. There was an error actually. Suman was Suman is from your firm, no? Sorry,
Yes,
I will.
yes, sir.
Okay, so that was a mistake. While sorry.
Okay.
Yeah, you're Sushant.
Yes.
Just a
So make
second.
me the presenter.
Yeah,
Sushant.
just a second. Just a second.
Sir, sir.
Sorry. So because while Suman was being okay, Ananda, please make Suman N as a co-host. Suman N. Ananda, please.
Yeah. So my slides are visible.
Yeah. Sorry
It's
for that.
visible,
In
right?
fact, I was trying to make Suman co-host and then he became the presenter. Sorry for that.
No problem. So it happens. Fine. Yeah.
Yeah.
So as I was mentioning, the vibrational spectroscopy and light microscopy, they're used for elucidating the chemical systems at the micron and submicron levels. Whereas, vibrational spectroscopy probes the detail of molecular composition. Light microscopy reveals the sample morphology based on the variations in optical properties. So vibrational microscopy or IR spectroscopy builds on the both of these techniques and thus provides a chemically selective visualizations of relatively microscopic samples. If you see in this slide, a small particle of the size of 100 micron with a normal FTIR or a normal IR spectrometer, it will have a challenge to get a selective spectra of this particle. But with a FTIR microscope, it is possible to spot this smaller particle and get a spectra of this selective particle. A most advanced design would be if there are many such particles, the complete area can be, mapped or imaged, and the software will help you understand what all are the different particles in the selected area. So going ahead, if I want to talk about plastic, so it is a more or the most prevalent type of a marine debris found in our ocean and the lakes. The debris can come in all shapes and sizes, but those that are less than 5 millimeters in length are termed as microplastics. Microplastics come from a variety of sources, including larger plastic debris that degrades into smaller and smaller pieces. In addition, the microbeads, it is a type of a microplastics, are very, very tiny particles of manufactured polyethylene plastics that are added as exfoliants to health and beauty products, that is the cosmetics, such as cleansers as well as the toothpaste. So these tiny particles easily pass through water filtration systems in the sewage setup, and they end up in the ocean, the lakes, and they basically pose a potential threat to aquatic life. I'd like to start with some reported statistics, although the statistics were around 4 years back. It was all based on the scientific studies performed in the span of 5 years or so. More than around 60% of the floating debris in the oceans is plastic. In fact, some studies estimate to be around 70%. Another important thing is to consider that not all that plastic really floats. So the amount of plastics that are there that can be considerably very higher. It is estimated that around 8 million tons of plastics enter the oceans annually. The sources of this can be from landfill, floods, storms, or industrial waste. One of the plastic enters the ocean will be moved around according to the 5 gyres that is shown in this slide. The rotating current within the ocean as shown in this particular slide in the right. As of the year 2009, around 267 species of marine organisms had been known to be affected by plastic debris. The larger mammals are known to have been trapped in discharged fishing nets and have been also known to be ingesting plastic bags. Approximately around 90% of dead birds in the North Sea have been found to have plastics in their stomach contents. The environmental group of 5 gyres estimates that maybe around 5.2 trillion pieces of plastics disperse in the oceans, with 1% of them being the size of a sand particle. Let me define and categorize the different kind of classes of microplastics to help you better understand it. So microplastics were initially defined, as I discussed in my previous slide, as being a plastics that are less than 5 millimeters in size. The definition is now more commonly defined to be plastics particles between few micrometers and 1 micrometer in size. The microplastics are split into 2 categories. One is primary and another is secondary. So the primary microplastics are the particles that specifically designed to be in a microscopic size. So they are used in the commercial consumer products such as cosmetic formulations. That is this things like body scrubs, shower gels, also as an abrasive materials in toothpaste. In industrial products, they are used as abrasive particles in air blasting products and also produced some commercially as plastic powders. The secondary microplastic, on the other hand, are smaller particles that are generated as a result of breakdown of larger plastic items. This breakdown can occur as a landfill sites, leading to a small particles that can be washed into the streams and rivers. Or the breakdown can occur in the ocean due to the wind, wave, and also because of the UV degradation. An additional source is a simple process of washing clothes. If I really want to give an example about. So what happens is, during the process of washing clothes, it will shed fibers that pass through the filters in the sewage system. A study has estimated that a single garment in the single wash can shed up to 2,000 fibers. Yeah, so that is that high, smaller particles. The term microbead. So if I want to talk about the microbead, it is oftenly used and used for many primary microplastics as such. Microbeads are used in hundreds and hundreds of personal care products. As I have already mentioned, a single product may contain thousands and even millions of microbeads, and some products could constitute up to 10% by volume of the product. The problem with the microbead is that they are so small that they readily pass through the filters used in the sewage treatment facilities, so thus they make their way into the river, lakes, and oceans. Microbeads will not be biodegradable, and hence they will remain in the environment for many years. They are ingested by various river, lake, or ocean species, potentially ending up the food chain. And another important fact is that they attract the persistent organic pollutants, that is the POPs, that are potentially toxic, such as plasticizers and pesticides. Now I'll move to the analysis of microplastics, starting with the analysis of secondary microplastics. The secondary microplastics we look here are the small plastic fragments that are caused by degradation of larger plastic objects. The infrared spectroscopy is an ideal measurement technique for routine identification of polymers and additives. Each type of plastic will have its own unique IR spectrum, or the spectral fingerprint, that gives an information of the chemical groups present. Extensive spectrum libraries are also available for automatic identification of the material from the IR spectrum. In addition, the sample sizes ranging from larger objects down to fragments of only tens to hundreds of microns can be routinely measured on a standard attenuated total reflectance sampling accessory with relatively no sample preparation, right? So the ATR, meaning the attenuated total reflectance accessory, along with the FTIR measurements, is done using the Perkin-Elmer spectrum 2 FTIR shown in the picture in the right hand side. The instrument is portable and can run off the battery pack. It also has the option of a wireless communication, allowing it to take it out of the lab to the area for performing the measurements in the field. The ATR sampling is extremely simple, as shown in the picture at the bottom of the slide. You just have to simply place the plastic on top of the ATR crystal element, which is mostly diamond. Apply the pressure and ensure the contact between the sample and the crystal. The whole process can be controlled through a software, which is Perkin-Elmer Spectrum Touch software that guides the user through the data collection and analysis. Now, Perkin-Elmer has been really active in a couple of environmental projects within Europe, especially. The first is within environmental campaigners, One Ocean. Their aim is to clean the coast, oceans, lakes, streams from the plastic debris and other harmful waste. The organization is headquartered in Munich, Germany. Their work with FTIR involves taking the spectrum 2 on board on a boat and measuring the infrared spectra of the plastic materials that are collected during the water cleanup process. The second project where the Perkin-Elmer were collaborative partners in this project was really undertaken by Furtwangen University in Germany. It was called the Rhein's Phaser project, or it was also termed as Swim for Science project. In this project, Dr. Andrea Feth, a scientist, he's also a keen long-distance swimmer. He swam an entire length of a river Rhine. Okay, the swim over 12 kilometers as sunlight. Was completed in a record-breaking time of 28 days. See the route on this map shown in this particular slide. So Professor Fath was wearing a collection of a device that would continuously collect the sample as he swam for the analysis by the support of the scientist. The spectrum 2 FTIR was used for the analysis of the plastic fragments en route. Smaller samples than the 1 millimeters were collected, and further analysis was done using the Perkin-Elmer Spotlight infrared microscope after the completion of the swim. So here we have the infrared spectra of most common plastic fragments recorded using the ATR sampling accessory on the spectrum 2 FTIR. Alongside each spectra, a search score obtained by searching the unknown spectra against the spectral library of the polymer material. A perfect match would be ideally 1, but the scores above 0.95 gives a reasonable confidence that the material is likely to be the same. So all of the search scores in this region are above 0.98, which shows an excellent matches. So in the order of the number of fragments identified, polyethylene terephthalate was most common, followed by polyethylene, polypropylene, and polystyrene. So if I want to talk about the typical sources of most common plastic pollutants, polyethylene terephthalate is mainly used for manufacturers of plastic drinking bottles. Polyethylene is most commonly used in the plastic bags used in supermarkets or the grocery stores, right? The polypropylene is it's commercially used as a packaging material. Polystyrene extensively used in the food packaging, known also as a styrofoam. All of these particles are recyclable. The another kind of plastics which are commonly identified as polyvinyl chloride, nylon, as well as polymethyl methacrylate. I would now like to move on to a study that is performed on the collection and analysis of microbeads, which are present in 2 commercially available cosmetic formulations used in the facial and body scrubs. Each of these products did list polymers among the ingredients. The analysis was performed using a Perkin-Elmer Spotlight 200i infrared microscope with a automated sampling modes. The instrument, though, can work on the different techniques like transmission, reflectance, and ATR. So the experiments were performed on two cosmetic formulations, as I mentioned, following the same, following some sampling procedure. I mean, the sampling procedure was same for both the formulation. A small amount of the product to be analyzed was placed in a beaker in a or a conical flask. Around 1 gram was sufficient. The smaller quantities are really preferred to obtain more isolated particles. So the two formulations shown here are in the photos are in the bottom right of this particular slide. Then 20 ml hot water was added. The liquid is then swirled until the soluble constituents have dissolved. You then have a solution in the new pictures at the bottom of this slide. So if you can see here, the microplastics particles are visibly and remaining in the solution. So in the formulation 1, there are many blue particles visible, but if these are zoomed, you can even see the white particles also. A lot of the blue particles are distributed over the edge of the beaker. The particles in the formulation 1 are, they actually don't have a regular kind of a size and shape. In formulation 2, the plastic particles are all white as seen in this slide, and they are mainly deposited at central area of the bottom of this beaker. So close inspection also shows that the particles are generally of the similar shape and size. The samples are then filtered through a 50 micron mesh as shown in this particular slide at the top of this slide. Although other mesh sizes could also be used depending on the requirement of the analysis, meaning the size of the mesh can also be varied. Now, vacuum filtration works slightly faster and dries the samples faster, although gravity filtration only takes a couple of more minutes as compared to vacuum filtration. That is a complete extraction procedure of the samples. The samples are now ready to be analyzed by an infrared microscope. Now, if I want to talk about an infrared microscope, it has a USB camera that allows the visible image of the samples to be observed as seen in this particular slide. Okay, so it allows to define the areas where you would like to perform the infrared measurements. So here are the visible images of the two formulations on 50 micron meshes. The formulation 1 you see to have irregular shapes of the particles. And they actually are of two colors. One is blue and white. The formulation 2, which is more further zoomed, it shows the particles are smaller as compared to the formulation 1, and they are of regular spheres that are trapped in the mesh sizes. Now, there are different measurement options to record the infrared spectra of these materials, and I will detail about it in my next slide. Yeah. So here are the different measurement approaches for the microplastics particles used in infrared microscope. So the sentences in green in a simple way are the positives of that approach, and the sentences that are highlighted in red shows the negatives of that approach. The spectra can be measured in the, firstly, the spectra can be measured in reflectance directly on a 50 mesh. So this is a very fast and easy measurement technique. However, the reflectance does not always give a good quality spectra. The spectra, then can be measured to transmission directly through the mesh. Again, this is a very faster and easier technique as there is no further sample handling required. However, the infrared spectra studies on the polymers are normally performed for the samples that are as thick as 50 microns. Otherwise, what happens is some of the bands totally becomes absorbing, so the saturation happens and the technique will really have a limitation to proceed. These microbeads are likely to be in excess of 50 microns thick due to the size of the mesh and the filter. Okay, so that is why it really will be a challenge, and we will see the spectra that are generated through this particular technique. And alternative to that is, transferring the particles onto an infrared transmission window, which is potassium bromide. Simply pour the scrap of the particles from the mesh onto the window material. Now this has the advantages which will obtain a good infrared spectra and a clear visible image, leading to a easier particle detection with the software. ATR is it is really possible and would be able to generate a best quality IR spectra, but as these are small particles, those particles may move under the force of the ATR and they can skip. And there is one more additional thread that some particles may stick to the ATR crystal, leading to the contamination of the subsequent spectra. So since we wanted to completely automate the operation, so this example, we have not used the ATR for the studies. Okay, so shown here are the spectra that are obtained for a same kind of particle through transmission as well as the reflectance microscope. So as you can see, both the spectra bands above 3000 wave numbers are totally absorbance, and these are saturation because of the very high thickness of the particle. The transmission spectra in the black is of much higher baseline intensity, and the reflectance spectra is in the red. So however, if the two spectra are graphically expanded, you can see that virtually these are very identical, so suggesting that either mode of transmission or reflection will give the same kind of result. So I have separated for your better understanding on this particular slide. So as I previously mentioned, though, a little luck will also be required for the samples to be sighted within the holes of the mesh. So if the transmission analysis is required, so that the metal the metallic mesh will absorb the IR spectra and not allow the analysis to perform. So in this study, we have what we have done is the particles of the formulation 1 were transferred to a KBR window for the transmission measurements using the IR microscope. So after they were transferred to a KBR window, the visible image was collected over the sample, and it looks like this. Okay, the PerkinElmer Spectrum 10 software has intelligent algorithms that will analyze the visible image, and it will find the particles that are present. So the image on the left hand side is a visible image to be analyzed, and on the right shows the particles that are detected within the visible image. So when measuring an IR spectrum on this microscope, you really need to match the aperture size and the background of that particular sample has to be done. So the particle detection algorithm automatically maximizes the aperture size for each particle to obtain the best intensity or the signal to noise for that IR spectrum. So after the detection of the particle automatically, that is done by the software, you just have to click on the scan markers button here. So it will automatically collect the spectra of all the particles that are identified here. Okay, so here is a zoomed area of the sample showing the analysis of these particles. So you have a visible image of the sample with the aperture positions used in the measurement of the spectra for each particle. So while the spectra of the particles are being collected, a search process is also happening in the background for identifying that particular particle. So in cases the particles those are identified as polypropylene, those are color coded as yellow, and the polyethylene particles are color coded as green. So this experiment or the study shows that it is really possible to extract the microplastics from a cosmetic formulation and perform the automated infrared microscope analysis to identify the microplastics presence. I would like to now describe two independent studies of microplastics done using a more advanced technique, that is FTIR imaging on PerkinElmer Spotlight 400 system. The first study was a part of a major study, the plastics and microplastics in the environment. A study to the microplastics in the river Danube was performed by the Austrian Environmental Agency. The second study was performed by the Brunel University in London, involved the samples that were collected from the water waste treatment plant in the UK, and the detailed sampling procedure before the analysis. I will also explain on that particular part. So here we have a real sample that was collected from the river Danube. So there are significant amount of dried materials of the biological origin in this particular sample. So however, it is possible to see that these plastic fragments can be removed from the sample matrix and measured using a FTIR using an ATAR accessory. The spectra of the three materials are shown in the right hand side of this particular slide, and those were identified as polypropylene, polyethylene, and polyamide respectively. The samples or the particles that are much more smaller, it is necessary to work with the IR imaging technique, that is IR imaging microscope. So in this case, infrared imaging microscope with a ATR imaging accessory was used to image across a larger region of the material. The larger diameter ATR crystal of 400 by 400 micron is brought into the contact with the sample, and images collected over the entire crystal size, collecting the spectra at each pixel of 6 microns. That generates a ATR image of the sample that can be tuned for a fixed wavelength, a total absorbance, or the principal component analysis as well. In this example, we see that the visible image of the sample on the left, the principal component analysis image is there, is explained on this particular slide. So the different materials will give rise to the different principal components, and they are represented by the different colors. So this allows for the easy recognitions of where the different materials are present in that particular image, which is the visible image. The blue and green colors in this principal component image are related to the microplastics material contained in the matrix, and were selectively identified as different kind of polyolefins. The final example in the is the collection of the samples from wastewater treatment plants. These samples are much more complex than the earlier example of cosmetic formulations, where it was extremely easy to isolate the microplastics using a hot filtration technique. These plastics are contained in the complex matrix, and separation is required prior to the analysis. So there is also significant amount of an organic matter in the wastewater samples that makes the filtration difficult, and it blocks the filtration. Okay, so hence the pre-treatment of water samples is extremely important before the analysis of the microplastics is being done. So the sample pre-treatment involved in this study uses hydrogen peroxide chemical. The hydrogen peroxide will dissolve the organic materials by oxidation. However, the analysis of the infrared microscope has shown that no observable degradation of polymers happens by exposure to hydrogen peroxide. So here we can see the differences in the filter residues after different lengths of the treatment of hydrogen peroxide. The control sample prior to the oxidation generated large amount of residue, which really blocks the filters. Vacuum filtration here took merely around 90 seconds due to the large amount of organic matter. As we progress across, we see that the longer oxidation times gives a cleaner filters, meaning the more organic matter is being digested and shorter filtration time can be achieved. So in order to test the methodology of the wastewater samples were spiked with 10 each polymers of polyethylene, polypropylene, polystyrene, and polyvinyl chloride. The particle sizes were varying from 150 to 300 microns. The particles were spinned and treated with hydrogen peroxide, and then the entire effluent was filtered out. The filters were then analyzed on the reflectance imaging on the PerkinElmer Spotlight 400. The imaging and the single point mapping will generate the same kind of result, but the imaging will give you 15 times faster because of the usage of the linear array detectors here. Okay, so here we can see the chemical images that are generated for the spiked samples. The chemical images are looking specifically for the different kind of polymer. So we can see here detection of polyethylene, polypropylene, polyvinyl chloride, and polystyrene microplastics. So all spiked particles are labeled in each plot, like the numbers are being given for the particles that are identified. Okay, so the reflectance spectra of the spiked particles are shown here, and these are easily recognizable as correct material. So the table on the right shows a success rate for the detection of the particles. So only 2 of the spiked particles were not detected out of 120 total, representing the success rate of more than 98% for this experiment. So this is how the complex wastewater samples can be isolated from the organic matrix, and FTIR imaging can be used accurately to identify the different kind of microplastics present. So this slide shows the complete FTIR portfolio for Perkin-Elmer that is recently renewed. So first is the Spectrum 3. It offers a superior spectral performance in all the 3 ranges of near IR, mid IR, and far IR. You can choose a range of single, dual, or triple configuration to meet the different application needs. The automated setup, the range switching allows you to move your sample quickly without any manual reconfigurations. The Spectrum 2 is a powerful, compact, and robust. So it is suited for a wide range of applications with a fully integrated universal sampling platform for the trouble-free measurements. It does have a portability options, and it is ideal for both the lab as well as the field testings if required. Okay, the Spotlight system. So these are the Perkin-Elmer microscopy systems. So these take the proven and the popular IR microscopy technique, and it really adds a new level of performance for the automations and application capability. So the products are Spotlight 150i, 200i, and Spotlight 400. So the Spotlight 150i is a perfect everyday point and shoot. I mean, the single point analysis can be very well possible in automated fashion. A range of intelligent features are there in this particular system, such as automatic illumination, aperture control cut, instrument setup that allows you to focus on the results very instantaneously. The Spotlight 200i, it really combines the hardware features of Spotlight 150i with the added ability to have the configurations with line scans and the area maps with the automatic stage operations with further intelligent software automation features. Okay, so optionally there is available a automated ATR with a pressure control which fully operates from the software with a pressure sensing mechanism to avoid any damage to the crystal being used for the analysis. The Spotlight 400 is Perkin-Elmer's imaging system, and it is a standard for the clarity for the FTIR image. So it delivers an exceptionally wide spectral range of choice with the selection of highly pixel sizes from 1.56 micron pixel to up to 50 micron pixel for different imaging application needs. It does have an optional large imaging stage that increases it increases the capability of analyzing large sample matrices. The Perkin-Elmer ATR imaging accessory, it captures the infrared spectral images up to 4 times higher spectral resolution as compared to the conventional transmission and the imaging techniques. It can measure diameters up to 500 microns. The Spotlight 400 system has a linear array detectors which incorporates high quality intrinsically pure MCT detectors which are arranged in 16 gold wire infrared detector elements. It has a duet detector which where a single element and a linear array are fitted, and the river in the same river it eliminates the the change over time. So if I do want to summarize my talk today, the microplastics are recognized as a major issues for the waterways, lakes, and the oceans of the world. The steps are being taken to introduce the legislation for eliminating, coming out of the commercial products. IR spectroscopy using ATR sampling is an ideal technique for identifying the larger particles above 1 millimeters, and IR microscopy and imaging techniques, as I explained in my later slides, can rapidly measure the as well as identify the smaller particles which are as low as 5 micron in size. The sample pre-treatment in the very complex metrics like wastewater samples with a chemical of hydrogen peroxide, which enhances and improves the selective capturing of the different kind of polymers in the microplastic samples, and it does helps you for countering the challenges that were conventionally available for analysis of those kind of samples. Lastly, I'll just take a minute of you to talk about the comprehensive solution that PerkinElmer provides to cater the industry segments and the mankind in this pandemic and the challenging situation. So PerkinElmer offers a RNA extraction system that is a multiple chemagic 360 for testing the real-time PCR, that is a polymerized chain reaction. Then PerkinElmer also offers a serological testing, the kits workstation for serum testing, the testing of the PPEs, that is the personal protective equipments using the ethylene oxide gases. We also offer quality control tool for hand sanitizer quality control for determining the efficacy of the larger sanitizers produced across the globe. PerkinElmer also provides a complete solution for food safety and the vaccine development. And just to add in on, May 6, 2011, PerkinElmer, which is a global leader, it is committed to innovating for the healthier world, has donated 1 million PerkinElmer COVID-19 antigen tests to Government of India to accelerate the testing capabilities across the country. With the support from US-India Strategic Partnership Forum, PerkinElmer COVID-19 antigen test kits will be distributed to the government hospitals and testing centers across the states in India, across 10 states in India. So with that, I end my presentation, and I'll just transfer it over to Kumaran.
Sushant, before that, can we take some questions on this session so that that connect is not lost?
Sure, sir.
Is it okay? Is it okay? Is it okay, Kumaran? It is fine, no? Because
Yes,
the other
sir.
topic is slightly different, so we will take
Yes,
questions
sir.
from this session. Yeah.
Yes,
No
sir.
problem.
Definitely.
No problem.
Okay.
Yeah.
So in the chat box, there is a question, but that is already answered. But still, I'll read. How to
Sure.
separate microplastics from other organic materials for analysis? So you were talking about H2O2 oxidation. Probably that is a good method, right? Any other methods?
Yes, I mean, so how is it? I mean, when I explained about the methodology of hydrogen peroxide, it is really for very complexing samples like the sewage effluent, which also has the organic matter in it, and it really blocks the filtration unit, and it really becomes difficult to identify the different microplastics. So it is a proven technique using a hydrogen peroxide solution. Apart from that, till now we do not have any other chemical that is utilized for extracting the polymers from the microplastics, from the organic matter, along with not having any detrimental feature to the polymers that are present. Okay, so the hydrogen peroxide has been proven to not have any challenges for working with the polymer samples. Okay, so that should be a very good option.
Okay.
If there are any other kind of matrices, we can share the kind of samples, and we can also have a discussion on that, sir.
Okay. Then Sushant, I have a few doubts. Like, how do we manage, say, sand matrix? Because we have been working on the beach sediments for analysis. So how to what we do is normal sieving, etc. I mean, for analyzing those very small particles, maybe of micron size. Do you have some suggested methods? mainly to separate, and then maybe analysis, whatever method you said could be fine, but how to separate?
So yeah, sir. So if we do know any extraction procedure, then it should be fine. But what normally is being done, sir, as you mentioned, the sand particles along with the microplastics are being taken. So if I want to talk about the very smaller particles, which are microbeads, so those are collectively taken on a IR inactive window, which is a KBR. Idea is to just have more concentration of the microplastics as compared to sand. So practically, it won't be possible to eliminate all the sand particles. So there will be some amount of your smaller sand particles, which is silica. So that should be fine. But it will also identify the different other kind of materials which are termed as microplastics, which are the polymers, which I also mentioned in my slide. So there is no set extraction technique from the sand as such. So it is just a filtration procedure, and just having the concentrated phases of those microplastics and viewing over the microscope on the system, sir, and then having a spectra for identification, sir.
Now, there is a question in the chat box that is from Preeta, Dr. R. Preeta. How to extract microplastics from aquatic animals?
Okay, so see, so the microplastics in the aquatic animals. So basically, what we can do is, I mean, what is being normally is being done, like the different NGOs across the globe. So they do samples different microplastics, not only from the different kind of waters, but from the animals also. And when I'm talking about the microplastics, these are a bit more in sizes, so which are visible to the human eye. So it is very well easier to extract out from those animals and analyze. I mean, as of now, that is what is being done. If you ask me that how the microplastics, which are very lower in particle sizes, can be extracted out the aquatic animals, so there is no any procedure as of now. It is only the larger particles, those are manually removed from the animals, and those are being analyzed.
Then I don't know, like that question, I'll just read out the question. Marine litter is a bigger concern. What methodology can be used for marine litter? Maybe the microplastics.
I really have to look into this particular topic, sir. I don't have any idea on this particular part. I'll note it down on my end, and I can get back to you on this.
Okay, Sushant, that is perfect. Now, I mean, another question. I don't know whether you are allowed to answer, but then what would be the price of that Spotlight 200 or 400 models? Approximate price. I don't want the exact price, but still an approximate price.
I really cannot answer this because the pricing part is not taken care by me.
Yeah, I understand that, but can you give a range at least?
No, actually, it does not goes in that way. So the range is really dependent on what complete set you take. Whether you also take some accessories with that unit. You also take some additional software there. So there are a lot of things to be considered for me to tell you about the price, sir. It is never a particular range of price. It always differs from the configuration to configuration, be it the normal IR microscopy, which is Spotlight 150i, 200i, and be it the chemical imaging system, which is Spotlight 400. So there are many flexible options that we include after discussing with you as well as the other customers, and we finally tell you the price, sir. Right, sir?
Okay. So then there is another question that has come in the chat box. Ashwini, I think you must be having question. It was your question, so you can directly ask Ashwini.
Actually, sir,
yeah.
Am I audible?
Yes,
yeah, you are audible.
Yeah, actually, if there is a heavily degraded material or the microplastics is having biological matrix attached,
yes,
will be the ideal time
soil sample, and for the end of the session we'll take up question. Suppose always we'll be having some doubt. So suppose if you are taking a glass of tap water, so which is not purified, So imagine that what it contains. It may contain metals, it may contain pesticides, it may contain some kind of anions like nitrates or sometimes even radioactive contaminant also, because those waters are not purified and maybe chances of heavily contaminated. So there are a lot of instrument technique it's available to determine the different kind of contaminant which is present in the sample. So in my topic, mostly we'll be looking after only the elemental analysis, which is like calcium, sodium, lead, arsenic. So those kind of metal, how it can be determined by using different analytical technique available in atomic spectroscopy technique. And you know, right, environmental pollution, it's a major concern nowadays. So environmental pollution can be defined as any unwanted changes in the physical, chemical, or biological characteristics of any component of the environment, such as water, air, soil, any kind of environmental. So that can cause some kind of harmful effect on the various form of life or the property of the environment. So type of pollution majorly described as water pollution, you know very well, right? So there will be a lot of changes in the water properties, like some water may be heavily polluted because of the industrial waste or what are the wastewater which is discharged from the industries like chemical, food, pharma, different kind of industry, as well as mines and metallurgical. So these kind of companies or industries, they discharge several organic and inorganic pollutants, right? So inorganic pollutant, which includes like different kind of metals especially, and acid and alkali related compounds. And organic pollutants, which includes oil, fats, phenol, and some kind of organic compound. And so these kind of pollutants are highly toxic to living beings. And also, we know like agriculture waste also one of the sources for the environmental pollution, which is like we are using different kind of chemical fertilizer and pesticides for farming. So these will give the potential toxicity to the soil as well as the water using for the particular agriculture purpose. And also, we know that marine pollution, again, we know very well that oceans are the nowadays sink of all kind of natural and man-made pollutants. And also last, the radioactive pollution, also one of the major pollution. So wherever the nuclear kind of energy they are doing, there will be a lot of waste which will be sent out. So that will be pollute our environmental completely. So these pollutants affect our environment in different way. And so we'll be having a lot of guidelines and regulation to control these kind of water pollution or some kind of environmental pollution. So what are those guidelines? There are a lot of guidelines starting from internationally and nationwide. In India, these are the specific guidelines which will give you information about what are the parameters need to be tested on water, specifically ISO 10500, which is for drinking water. So this method covers a different kind of chemical analysis, starting by like pH, conductivity, sulfate, nitrate, those kind of chemical analysis, as well as metal analysis. So what is the amount of toxic metal present in the water, or nutritional metal, or different kind of pesticides and polyaromatic hydrocarbons and microbiological tests. So these are the different parameters we'll be testing in the drinking water. So in that, metal analysis also one of the technique where you need to determine the metal in the different kind of water sample. And these are the other metal like 14543 for packaged drinking water and 13428 for the natural mineral water. So these will give you the specification limit, what is the acceptance criteria for those contaminate which is present in the water, as well as some kind of instrument technique also. And if you see globally, there are a lot of methods out there to describe or to determine metal by using different kind of instrument technique like ICPOES and ICPMS. So ISO technique, we know very well that which is international standard. So they also having some method to determine the metal by using ICPMS and ICPOES. And EPA, United States Environmental Protection Agency, also having two different topic which will describe you determination of metal in water and wastewater by using ICPOES and ICPMS. For soil, also for IS, there are some methods available, and also there are different other regulations also which will describe you like measurement of air pollution, and also to meet different kind of regulation across the globe. And also we'll be having always whoever doing the water testing, they will be aware of this standard methods for examination of water and wastewater, which is like APHA. So this will be the ideal tool to determine the different kind of parameter from in the water. And these are some other guidelines which will specifically related to the pollution. So CPCB, we know that Central Pollution Control Board, they having different kind of quality standard like water testing and ambient air quality. So specifically in air, we can imagine how air can be tested, even though because of the industrial pollutants. So the air also will be contaminated heavily. So these are the metal which we need to be tested in the air itself. There are specific instruments out there which will collect the, which will be used to collect the sample from the air, and that particular component will be tested by the instrument to determine the heavy metals. And also for the soil quality, also there are some quality standards are available. So where we need to test the minerals, micronutrients, as well as the heavy metals. So those are the different methods available for that. And also this is a WHO guideline for the analysis of different metal and their limits. You can see that the limit always very, very less, which is like almost less than 1 ppm. Most of the element is almost less than 1 mg per liter. So this limit of day by day it's coming down. So we need to have the technique which can able to determine the element which is at very trace level. And also what is the frequency of this kind of water testing, right? So chemical parameter need to be tested once in a year, and microbiological related tests need to be done yearly twice. That means the before and after monsoon. And these are the limits which is provided in the different IS standard of different IS standard and the metal and the limit what we given here. And this is a global guidelines where they given the specific, almost if you see the regulation, it almost nearby that, because most of the guidelines they will follow the globally recognized specification only. And recently in IS 1453, uranium also added one of the parameter need to be tested in the water sample. Because of this, uranium contamination observed across India at different regions. So they included uranium also another parameter which need to be tested. And you can see right here, we need to test almost more than 15 to 16 element in a water sample. It may be drinking water or packaged drinking water. So you need to have the instrument which can able to determine all the element in the single run at a different level, because this metal you can see, right? So they given few metal, they given very high level because those are the mineral elements. So their presence always will be more in the water. So few element which may be introduced into those water source by the different kind of pollutants. So those level will be very, very less, because these elements are highly toxic to humans as well as the environmental. So that is the reason the few element, the limits are very, very level. Even you can see some limits are even close around 1 ppb. So to determine these elements, atomic spectroscopy is one of the recommended analytical technique to determine the elemental content in various sample matrices. So atomic spectroscopy is nothing but it's a kind of study where you can able to evaluate the electronic radiation absorbed or the emitted by the different matter, because the element having different kind of properties. Either it will emit some kind of energy under some specific reaction condition, or it will absorb some kind of source. So based on that, you can able to determine the elemental composition which is present in the sample. So those are the techniques like atomic absorption and inductively coupled plasma optical emission spectroscopy and inductively coupled plasma mass spectrometry. So these are the three different techniques can used to determine the metal content which is present in the different sample matrices, including water or soil sample as well. So again, we have three techniques. So out of three techniques, which technique we can consider? So thing is, so what is the range our instrument can cover? What is the load detection limit it can cover? So depends on those things. You can able to consider the different instrument technique. The first instrument is flame AA, right? So flame AA having the two technology in it. One is flame AA, another one is a graphite furnace. So graphite furnace can able to cover ppb range of analysis, and flame AA can able to cover ppm range of analysis. So put together flame and graphite furnace, you can able to test the element ranging from ppb to ppm level. And ICPU, again, one more limitation AA is it's a single element technique. At a time, you can able to determine one element only. So that is the only limitation in the AA. And ICP-OES, again, it's a multi-element technique. You can able to determine all the element in the single run. Suppose if you want to do 20 elements, 30 elements, you can able to cover in the single run. So that is a advantage technique when you compare to AA. So here you can able to cover the range from ppb to up to percentage level. So entire range, that means starting from ppb, ppm and 1000 ppm, those level can be easily covered by the ICP-OES. And when you come to ICPMS, ICPMS is specifically designed for like trace element impurities analysis. So where you can able to cover the range from PPT to ppm. So ICPMS is one of the ideal techniques where you can able to use for analysis of different metals when you especially looking at trace levels. Again, this is one more slide selecting the suitable technique. So when you are having when you want to select the technique, before these are the consideration, you can look around and you can select the instrument technique. So suppose the lab, anyone lab, they are having very few samples and they want to test only 2 or 3 elements. A is the one of the technique where you can consider, because you are having very small volume of sample and very limited element, then AA will serve you better because it will cover both PPB and PPM level. And the lab, whether they are having multiple sample and they want to test the range starting from PPB to PPM, and they are having very they want to test more number of elements, then ICP-OES will come into picture. And when they say they want to go for very low level like PPT and PPB level, and they want to test lot of element in lot of sample, then ICP-OES or ICPMS will be the suitable technique. Again, the choice will be depending on the what is the low detection limit you are looking for and what your regulatory requirement is asking, like IS or UCPA or WHO. So what, that guidance, what they are telling, which instrument to consider. So it depends on the choice. You can select either of the technique. By considering the elemental dynamic range of the 3 technique, ICPMS is one of the ideally suited technique for analysis of all kind of metal in any kind of sample, because it can able to cover PPT to PPM level. So it is easy to determine all the element in the single run. So ICP-OES, ICP, both are ideal technique. Comparing ICP-OES, ICPMS having some advanced technique. So I can explain to you in the coming slide what additional benefit you can get from ICPMS when compared to ICP-OES and AA technique. So we know, right, why the metal analysis is required, because in water sample there are a lot of metal you want to determine, right? So why it's required to determine the metal content in it? The first thing is, you know, right, in periodic table there are a lot of metals are there. So there are some metal which is nutritional to for our for humans, like sodium, potassium, calcium, magnesium, iron. So these are the nutritional metal which will be present natively in any product like water or some kind of soil, or it will be added to enhance the health benefit for the whoever consuming that product. And this nutrition element will be always present in high level or some level, because nowadays we know, right, because of this COVID situation, doctors are suggesting to take zinc multivitamin tablet. So what it does contain, it contains some kind of minerals which will improve our metabolic function. So that is the reason. So these are the nutritional metal which is useful for humans. And also few metals are very toxic to humans. Those metal we never add to any kind of food product or water. So that will be entered into food or water through different kind of processing, like contamination or pollution or any kind of different activities. So those metal will be added into the environment. So these metal basically present at very low levels on the ppb or some type microgram level. So these elements will present in very high level. So therefore, so we need to test all kind of sample, including food or water, any kind of sample matrices. We need to test both nutritional metal as well as a toxic metal to understand that how that whether the particular product is safe for consuming or that will be rejected for the consumption. And heavy metal, you know, right? Heavy metal is highly poisonous. Those elements are like which is having high density and which is very toxic even at very low concentration also. So these heavy metals are well-known environmental pollutants because of their toxicity, and they like unlike other, like suppose for example different other pollutant like organic pollutant that may degrade over a time. But heavy metal like which is very highly mobile and it's not at all biodegradable and it's easily can be accumulated into human beings or the living organism, and it will not be degraded or destroyed even at any kind of process. So that is the reason the control on the heavy metal analysis is highly recommended. So what are the sources can be tested during the particular, when you're talking about environmental sample? So water, soil, air, and finally food. Because food, why it's food need to be tested. So because if you're taking different kind of food we are taking, right? So that will be come from the soil only. If soil is contaminated or water is contaminated, so ultimately that will enter into food chain and it will give adverse effect on the humans. So that is the reason these are the main sample which need to be tested to check the metal content in the ecosystem. So this is like one slide which will be give you information like heavy metal pollution in India river. Heavy metal pollution, particularly in the different rivers they tested. So where they identified these element which is present at very high level when it compares to the different regulation limit. So these are the metal which is always present at very high level. So you can talk about lead, chromium, cadmium. These are the highly toxic element. So these are present in more number of rivers like. So these are the number of rivers they tested these metals. So which is present more than the permissible limit of this, which is mentioned in the different regulation. And also in India, there are 18 districts they tested the different water sources. So there they identified number of districts which is affected because of the pollutants, like starting from arsenic, lead, chromium. These are the major metal pollution. But lead and cadmium, these are the metal which is present high in different water source across the India region. And this is one more thing, as I said, uranium is one of the major pollutant in India. So which is coming from the, mostly from the groundwater only. So because recently in India, the Department of Water Resources, which they tested uranium in different water sources across India, almost 16 states, where they identified uranium is present in almost all the states across India. So by considering this one, Bureau of Indian Standard also they set some permissible limit for uranium, so which is 0.03 milligram per liter, nothing but 30 ppb. So this is another information they tested in different states. So where there are multiple sample they have analyzed it. In that sample, so they will be getting some good amount of uranium in different samples they collected from across the India. And you can see maximum they identified is around 3 ppm, and minimum they get 1.45 ppm. So there are different concentration of uranium which is present across the India. So that is the reason the uranium also one of the test parameter we need to cover during the water analysis, particularly environmental sampling. So these are the like different metal need to be tested in the environmental sample. And what are the technique? We know the technique, right? But how the technique it will be working, right? I will be taking you some slide of the basics of how AA work, how ICP works. So atomic absorption spectroscopy is basically a kind of technique where you can quantitatively determine the chemical element. So here in this instrument, either AA or ICP, or you need to use liquid sample. So whatever the liquid, in homogeneous liquid sample, we need to aspirate because the metal will be in dissolved form in those particular medium. So all the sample need to be aspirated in the liquid form only. So for AA, what are the requirement is first you need to have the primary light source. That means, so whatever the element you are determining, so those light source will be used to emit the particular light wavelength, and followed by the one source which is called a flame or furnace, because the liquid sample will enter into the flame, so where it will be forming the free atoms. So this source will emit some specific wavelength. So that whatever free atom formed in the flame, so that will get absorbed by the particular wavelength. Suppose copper means if you place the copper lamp here means, so that will emit copper wavelength, right? So what are the free copper atom that will be get absorbed by these wavelength, right? So what are the absorbed light that will be measured by the AA. So light source will emit the light and flame will generate the free atom, and what are the light absorbed, right? That absorbed light will be separated by the monochromator. So that will be determined by the detector. So this is the process of AA. Second AA, when you come to AA, there are two techniques, only the flame AA. Here atomizer source is flame. That means in the flame, which is a like source which will give around temperature 2000 degrees centigrade. At this higher centigrade, under this temperature, what will happen? You will be getting the free atom, right? So that is why we can use two kind of flame. One is air acetylene, and second one is acetylene nitrous oxide, which will give both the different temperature. And also, this technique is very good for ppm range of analysis, where you want to go for 10 ppm, 100 ppm. So flame AA will be the one of the recommended technique, and it's one of the fast technique. Even within 10 to 15 seconds, you can be able to complete one metal analysis. And background correction also available. So by using this flame AA technique, you can be able to determine minerals and microminerals in environmental sample particularly, and as well as pharma and food. For example, like sodium, potassium, you can be able to determine using the flame AA, which is present at eye level. And graphite furnace, it's a similar technique, only one technology will be changed. Instead of flame, they will be using electrically heated furnace, which will give temperature around 3000 degrees centigrade. And because of this technique, this graphite furnace technique, so you can able to go ppb level. So you can easily cover the very ultra trace level, and it will give you better detection limit for many elements. And also it will be using one technique called GMET to correct the background. And common application you can use for all kind of heavy metal analysis in environmental and pharma food when anyone looking at very low level. So one want to test ppb level, furnace will be recommended, and AA for the ppm level of analysis. So put together graphite furnace and AA, it's a single instrument. Either you can get both technology in single instrument, or either of the technology you will be getting the instrument. And again, cold wrapper, it's an additional technique where you can able to do like hydrate forming element like arsenic, mercury, selenium. This is another technique used in the AA only, especially to detect arsenic, mercury by using the AA. So next, inductively coupled plasma. As I said, AA is a single element technique, and suppose one want to do 15 elements or 20 elements. So the recommended technique is ICPOES. So ICPOES, again, the sample should be in the liquid form. So here also source will be there, because each instrument having the source. So what it will do, it will separate your interest of parameter, what you are going to determine. So here in ICPOES, plasma is the source which will be used to generate the metal ions. So plasma is there nothing but it's a highly ionized argon gas which will give temperature around 8000 degrees centigrade. So how the plasma will be formed is, so the argon gas is purged into the middle of the plasma, middle of the torch. So the RF power will be applied to the particular argon gas. So when the power is applied, the argon gas will collide with each other. It will generate the source like that, which is called a plasma. So the temperature of the plasma is very high. So when the sample is introducing into the particular medium, so we know, right, metal contains nucleus and it's surrounded by the orbital. So orbital having electron, right? So any energy source like heat or something which is applied to the metal means the electron which is present in the outermost orbital, it will absorb the energy and it will go to the excited state, right? Which is called excitation. So you know, right, the electron will not stable at excited state. Again, it will come to ground state. Again, when it's coming to ground state, it will lose some energy. It will emit some kind of light. Light means nothing but it's a wavelength, right? So the emitted wavelength will belong to some specific metal. So copper means 320, lead means 208, and arsenic means 195. So each metal having the specific wavelength, right? So by measuring the specific wavelength, whatever the light emitted, right, nothing but the wavelength. So that emitted light is proportional to the amount of metal which is present in the sample. So in that way, ICPOES will work. So that means the plasma will generate your ions by excitation process, and this different optics which is present in the ICPOES. So that will give you, that will separate your interest of wavelength. So that wavelength will give you like what element present in it and what is the amount of metal which is present in that sample. So those information you can able to get it from the ICPOES. And AA and ICPOES, basically it will measure the wavelength of the particular metal. So whatever the metal it will have some specific wavelength. So that wavelength will be measured by the ICPOES. So by using this ICPMS technology, you can able to cover the wavelength starting from 165 to 900 nanometer. You can able to cover both UV and visible range, and even you can able to cover low UV range also, which is less than 200 nanometer. And what is the one more advantage of this ICPO is it's a multi-element technique. Because AA, we have to do the element one by one after another. So if you want to do 10 elements in a sample, AA required 10 times. You have to aspirate the sample 10 different times by plotting the suitable calibration. Because these techniques are comparative technique. First, you need to plot the calibration graph followed by the sample. So by using the calibration graph, you can able to determine the amount of metal present in the sample. So what are the components of ICPOES, right? So ICPOES, it's a like liquid technique, right? So we need to introduce the sample into the particular ionization source. So these instruments having the different component like peristatic pump, which will take your sample, and nebulizer spray chamber. So nebulizer will spray your sample into the spray chamber with the help of the argon gas, and in the torch argon gas will generate the plasma. So these aerosol will enter into the plasma because of the high temperature of the plasma gas. So those liquid sample will get vaporized. Only metal will remain same because metal will be present in different form like sodium nitrate or lead nitrate or some kind of nitrate or hydroxide form. So those will be separated from the water molecule during the vaporization. And secondly, these molecule will dissociate into individual ion. So maybe whatever the metal ion, maybe copper or zinc or iron. So after that, this kind of excitation process will happen, and the light will be separated by the spectrometer, which is a part of ICPOES, and the separated light will be determined by the detector. So you know that each instrument comes with a specific software to read out the parameter which is generated by the instrument. So that software, through the software, you can able to get the information what are the elements present in the sample and what is the quantity of that particular element. And third technology, which is ICPMS. So again, it is also similar like ICP only. Here also the source is plasma only, so which will be generated by with the help of the argon, right? Again, by using ICPMS technology, you can able to determine the elemental composition of the sample, and here ion source is the plasma, which will convert the gas phase atom into ions. So how it works again, you know, right? As I explained, the metal contains nucleus and it's surrounded by the orbital, right? So when this metal enter into the plasma region means what will happen? So the metal will absorb the energy from the plasma and it will eject an electron from the outermost cell. So during the excitation, it will emit one cell, right? And thereby it will form the positively charged ion. So whatever the ion extracted, the positively charged ion is measured by the quadrupole mass analyzer. So in ICPMS, there will be spectrometer will be there, but in ICPMS, quadrupole mass analyzer will be there. That will filter out your ion as per mass to charge ratio. So that is a function of the quadrupole mass analyzer, and detector will determine the signal. Whatever the signal coming from quadrupole analyzer, it will be able to determine the amount of metal which is present in the sample. In ICPMS, we are determining the masses of the analyte. In AA and ICP, it's a wavelength, but in ICPMS, it's the mass of the ion. So in that case, you can able to cover the mass range from 2 to 285. So practically, you can determine the low mass, which is lithium, to the higher mass uranium in the single go by using the ICPMS technique. And what is the one of the additional advantage or additional benefit you will get from ICPMS is it will able to determine metal concentration at very low level, let's say PPB and PPT level. So that is one of the additional advantage of ICPMS. You know, right? Most of the mass technique, which is basically used to at low level of analysis. So that is also here meant for ICPMS technology. Second, we know that ICPMS, but how ICPMS works. In this image, you can able to see the orthogonal design of ICPMS technology. So where different components are starting from torch, which will generate the plasma, and the cone, which will filter your ions, and the deflector, which will deflect the positively charged ion, and the cell, which will remove unwanted interferences like polyatomic interferences, and quadrupole mass analyzer, which will filter your ion as per mass to charge ratio. And finally, we have the detector, electron multiplied detector, which will detect your metal of interest. And each part will work here, we can see. So first ICP will generate the ions, maybe copper plus or some kind of unionized material. So cone will reduce the atmospheric pressure and it will enter your ion into vacuum, because most of the mass instrument operate under vacuum region, right? So the cone will allow your enter your ion into the mass chamber, and also it will reduce the pressure in the that means when element enters from atmospheric pressure to vacuum pressure, there should be some difference will be there. So with the help of the cone, that also can enter, and deflector will deflect only your positively charged ion, right? So because our interest is only copper only, we don't want to determine hydrogen or chlorine because this is unionized material, right? And these only copper plus only we want. So with the help of the deflector, you can able to deflect your positively charged ion. Again, here you can see, right, we want determining copper only. We don't want this argon oxide or argon chloride, right? This is called interferences in the ICPMS. So these interference can be removed by using the cell technology. So each ICPMS having some technique called cell technology. So thereby you can able to remove these kind of interferences, right? So that can be done by using the cell. Followed by the quadrufold mass filter, which will be filtering your ion as per the mass to charge ratio, and followed by director will determine the metal concentration by converting the electronic, by converting this signal into electronic signal. You can able to determine the thing. Again, similar process only here also, like same ICPO is, but only thing after the plasma entirely it will be different. ICPO is having completely optics, lenses, those kind of setup, optics, lenses, prism to separate the light. But here it's a completely mass kind of thing. We'll be having different kind of separate like deflector, cell, and quadrufold analyzer to determine the metal content. So these are the three techniques how it works. And second, most important thing when you are dealing with any kind of analytical instrument, sample preparation is one of the major thing, because instrument will determine whatever we are analyzing, right? Whatever we are introducing into instrument, that will direct. So important thing is the sample preparation and the method development. So these are the process during the sample analysis. The first thing is the sampling. Suppose you are getting water or soil, so we need to collect some sufficient quantity of sample. If water means maybe 1 liter or 2 liter required, because you need to test different kind of parameter, right? Maybe for metal analysis, 100 ml will be more than enough. But if you want to test other parameter also, at least minimum 1 to 2 liter required. And we have to think about sample preparation. What kind of sample preparation required for this particular sample analysis? Maybe it may be UV or FTIR or GC or ICPMS. So particularly when you come to atomic spectroscopy like ICP or ICPMS, so you need to go for the liquid sample only. So whatever sample you are getting, it should be in the clean liquid form. There should not be any particle. So like there should not be any dissolved particle, there should not be any stone, there should not be any kind of organic matrices in the your water sample. So accordingly, either you can go for the filtration to remove that particle, or you can go for the acid digestion. So for the acid digestion, you can use either of the acid in this, but nitric acid is one of the recommended acid for any kind of sample preparation, because nitric acid is oxidizing agent, right? It will decompose any kind of matrices which is present in the sample. And also most of the element will be stable in the acid medium only, that is preferably nitric acid only. And hydrogen peroxide, hydrochloric acid, sulfuric acid, hydrofluoric acid can be used along with nitric acid whenever required. When you are having complex sample like soil or any kind of effluent sample, right? So that requires some kind of heat treatment, like we have to decompose the sample, right? So that time you can use combination of different acid what I mentioned here. And after that, you will be introducing into the instrument. So before introducing to instrument, you need to develop your method. So developing a method here is what kind of metal you want to determine. Suppose if you want to determine 15 metal or 16 metal, you need to enter all the information in the software as a metal. So it depends on the instrument, ICP or ICPMS. ICP means wavelength will be selected. ICPMS means mass number will be selected. And you have to calibrate the instrument by using known calibration standard like 1 ppm, 2 ppm, 3 ppm, right? So you'll be getting the calibration. After getting calibration, you will be analyzing sample, and by using that particular calibration graph, you will be getting the amount of metal or something which is present in your sample. After that, you can evaluate the data, whether the calibration graph is correct, and what are the sample we aspirated, you are getting the correct results, whether the QC checks are okay. So all you can evaluate, and finally you can report the result. This is the process what you can do in the regular day-to-day analysis when you are using analytical instrument. So these are the chemicals and glasswares required when you are dealing with ICPMS or ICP-OES. And when you come to sample preparation, there are ICPMS or ICP-OES require neat and clear solution for introduction, because these instruments having very fine sample introduction thing. So where it will get choked if a sample contain any kind of dissolved matrix or any kind of particles in it. So these are the different sample preparation you can use to prepare the sample. One is a direct dissolution. If sample is readily soluble in water, like for example, table salt, if you add pinch of salt in the water, it will easily dissolve, right? So those kind of sample, if you get for metal analysis, you can directly dissolve in the water and you can do for that. Second thing is extraction. So extraction means, suppose if you have soil sample, any kind of sample, so you want to extract only metal, what it can be extracted during that particular time. So those can be used for the particular extraction procedure. Again, in this case, what will happen? The complete metal will not get extracted. At the particular time, what are the element can be extracted? So that will be extracted in the medium. That medium can be filtered and analyzed by ICPMS. And third technique is digestion by using eating. By eating the sample, you can able to digest, because in this technique you will be getting some undissolved matrix, right? By using autoplate or microwave digestion, you can able to decompose the sample completely, and you can get the complete sample matrices. You can get the clear liquid sample like this, what I shown here. So that can be used by autoplate and microwave digestion technique. Suppose if you are getting water for the analysis of metal content, if the water is free from any kind of particle, just you can acidify with some amount of nitric acid, because nitric acid is preferred because of its oxidizing nature and the stability purpose, and you can dilute if it requires. Suppose if any metal present more than the calibration gram, you can dilute further during the analysis. And suppose if you are getting industrial waste like sludge or effluent, you know, right, these sample contains more particles and organic matrices, right? So those you cannot able to aspirate directly, because there is undecomposed sample also there, and those sample can be digested by using microwave digestion or hot plate. Why microwave digestion here I am recommending is, so you know, right, when you are digesting in hot plate, there will be chances of sample spilling around, because the heat cannot be controlled. By overheating, the sample can be spilled out, and there will be chances of contamination from the outside. So that is a limitation in the hot plate digestion. When you are going microwave digestion, this will be completely done in closed environment. So you can avoid sample loss, and similarly you can avoid the metal loss, and you can control the contamination. So solid sample means you can take 0.5 to 1 gram sample, and you can use nitric acid as recommended, depends on the sample matrix, starting from 5 ml to 10 ml, and nitrogen peroxide will be added to increase the reaction rate. If you are getting liquid sample, and 5 to 20 ml can be used, and again acid also depends on the sample volume, you can use 5 to 10 ml nitric acid, and it can be kept inside the vessels. And this is a temperature program which you can give it to microwave digestion. This microwave digestion nothing but whatever we are seeing like commercial microwave oven, what we are using in our home, right? Similar kind of setup only. The heat will be applied to the vessels, which will decompose your sample. By applying heat using microwave, we are going to heat the sample. So that is basically what we are doing with the ICPMS. Suppose you are getting soil sample for analysis of metal. So one thing you can do extraction by using different kind of buffer. And second one is a digestion, either by autoplate digestion and microwave digestion. So these are the different acid composition you can use for soil extraction or digestion. And HF is recommended because soil means it is nothing but sand, right, which is contains silicon. So silicon, it will not decompose in nitric acid medium or any other acid medium. So we need to use some amount of hydrofluoric acid to decompose the sample completely. And when it comes to air, so there are a lot of instruments like respirable dust sampler. These instruments will collect the sample in the filter paper. The filter paper can be digested and it can be used for the elemental analysis. So starting from air, soil, water, all the sample preparation provided here. By using this technique, you can able to prepare these sample matrices, and you can able to test those sample by using the instrument, and you can able to get the metal, what is the amount of metal present in those matrices. And also when you come for standard preparation, we need to know which acid matrix those metal will get stable. So if you see that standard CRM standard bottle means they will mention what kind of acid matrix used for this stability. So similar kind of acid you can use for standard preparation, and better practice is you can use what kind of acid used for sample preparation. Similar acid and similar composition can be used here. And one more thing, when you are determining mercury, you know, right, mercury is highly volatile. It will not be stable. To keep the mercury stable in your solution medium, gold can be used in all your blank, standard and sample for the mercury stability. So you can use 0.1 to 1 ppm to keep the stability of the mercury. This is one of the important things when you are doing mercury analysis by using ICP and ICPMS. And here are a few metal analysis which is done by AAS and ICPMS and ICPMS. So as I said, if it water sample, you can simply acidify by using the nitric acid. And as I said, in AA, we are determining the wavelength only. So that wavelength is meant for some particular element. You can see here copper, iron, manganese. So these are determined, and these are the calibration range. You can see, right, different calibration range we use. So minimum you can plot 3 linear. The minimum 3, maximum you can go more than 5. But minimum you have to plot 5 calibration graph required. Suppose if you are working in any kind of enable aggregated laboratory or something, so you have to plot minimum 5 graph, 5-point linearity to get the calibration graph. And even if you want, you can reduce the graph to 3 also. So these are the instrument parameter like gas flow used for this particular analysis. So these are the amount of metal which is present in the municipal water and bottled water and the mineral water, which is reported here as ppm, mg per liter. You can see most of the element which is under control only. You can see sodium, it will be little bit higher because it's because of salt of water, because all the water itself will contain some amount of sodium, calcium, magnesium, potassium. So those level will be little bit higher only, and this level of metal will not affect our human. So this will be within the limit only. And few metal like copper, iron, these are the very low level. So even that also you can able to determine the AA technology. And when you want to determine lead and cadmium in trace level, so furnace technique can be used. So the furnace means, again, instead of flame, we are using graphite furnace, and this is nothing but lamp type HCl and EDL lamp, so which is the source of the particular metal. And when you're using furnace, some matrix modifier can be used. So if anyone are AAS user, they know very well what is the function of modifier. It will separate your interest of metal. It will keep your metal during the particular atomization stage. So these are the lead result, which is determining the different soil sample, and which is basically done in some of certified reference material where we can able to get good recovery of those metal. So when you want to go for trace element material, you have to use furnace, and when you want to go for minerals, you need to use the flame with the AA technique. And this is another application study, the analysis of drinking water and packaged drinking water as per our IS standard like 10,500 and few other standard by using ICPOES. So here again, these water, you know, right, drinking water and packaged drinking water free from any kind of particle, right? You can directly acidify with 2% nitric acid. That will take 50 ml of water and acidify with few ml of nitric acid. So that will give stability for your metal. And these are the flow of gas. You know, right, ICPO is required argon gas, right? So argon gas flow is 8 liter per minute. And nebulizer flow, nothing but it will nebulize your sample as a aerosol. So that flow is mentioned here. And these are the metal which is tested, and these are the results you can see, right? So the drinking water which contains high amount of minerals like boron and few other metal like sodium and all, right? And you can see they compare with 14543. So these limits almost close to that, but you can see like boron which is reported in microgram like ppb level. So most of the limit well within the limit only. You can see, right? 95, it's a ppb, nothing but 0.95, which is less than 5 ppm only. And also few metal which are very lesser than the detection limit, which is mentioned as a less than 1 ppb. And this is a packaged drinking water which we tested, where we identified some amount of copper and iron and even magnesium, boron and barium, and few toxic metal like arsenic, mercury and lead, cadmium. These are under very low level. So that means these waters are safe for drinking. And also to ensure that accuracy of this method and sample preparation, we spiked some amount of known amount of metal in the sample, and we can able to get the good recovery within the range of 90 to 110%. That means whatever the method we are using for sample preparation and the instrument technique that will ideally able to recover your metal which is present in the water samples. And also, right, ICPOS user knows hydrate generation technique which is ideally recommended for PPB or low level analysis for arsenic mercury. So these are the pre-reduction chemical which is generally used for the analysis of arsenic mercury and selenium by using ICPOS technique, because this metal ultimately which is present in PPB level, right? When you want to determine PPB level by ICPOS, you need to use hydrate generation process, which is again another process. In this technique, what we are doing, we are separating the metal from your sample matrices by using the reduction solution. So that is called sodium borohydrate. So that will reduce your arsenic or mercury, and it will separate from your sample matrices. That particular form will be determined by the ICPOS. So this is another technique where metal determined in the soil sample. And here soil sample, right, it's a solid sample. It won't dissolve in as water medium. So here we digested by using this acid composition. You can see we took 0.25 gram sample and different acid we use, like nitric acid for decomposition, HCl for the digestion, and HF to digest the silicon matrices, and perchloric acid to increase the reaction rate. And after digestion, this sample is diluted to 50 ml by using deionized water. Because direct acid we cannot able to introduce in the instrument. This digested sample need to be diluted by using the water, normal deionized water or DM water or DI water. And these are the results observed for the almost 20 plus element. So where we got very good recovery. Here we are not reported you the exact result. It's like recovery of the sample against their certified value. And these are the calibration range. We plotted the lower range and higher range. The lower range nothing but the calibration blank, which is 0, and in between that 3-point or 4-point calibration can be plotted. And this is the instrument parameter to determine the metal content in that particular soil sample matrices. So this is also another metal analysis of in wastewater by using ICPOS by following the EPA 200.7. Again, here also sample preparation is very simple. 2% nitric acid is acidified. By using nitric acid, you can able to acidify the sample. This is the calibration range. So here we used only 2-point calibration only. You can see the low concentration metal calibrated at low level, high concentration metal like metal calibrated at high level. So these are the results what we determined by using our ICPOS. Different wastewater we analyzed, which is having low content of metal, high content of metal, and also wastewater also. You can see the metal will be determined starting from 0.07 ppm to highest value of almost 2 ppm or 3 ppm. So different level can be able to determine by using ICPOS in single run only. So no need to go for multiple run. By single run, you can able to do all the elements. Again, this is analysis of better by using ICPMS. So again, sample preparation similar like all the instrument technique only. Just acidify with 2% nitric acid if there is no any particle in it. As I said, gold can be used for mercury stability and also to minimize the mercury carryover also. Because mercury memory effect will be more in ICPOS, ICPMS. With the help of gold, you can able to reduce that memory effect in ICPMS. So intervention is another topic which will improve your quality of results or which will correct the variation during the sample aspiration or ionization. And this is the calibration graph what we prepared. All are in ppb level only, microgram per liter. And these are the low metal which we plotted 1 ppb to 100. And for sodium magnesium, we started from 100 ppb to 10,000 ppb. And these are the internal standard we use is cadmium, gallium, germanium, indium. And these are the instrument parameter. And these are the results what we get in the reference material. So reference material means a certified reference material. 3 reference materials are analyzed. So all the metal recovery are well within the 90 to 110%. So this is again spiked sample. So where we spiked known amount of metal in wastewater and the recovery are well within the limit. So this confirms you the technique ICPMS or ICPOS ideally suitable for the metal analysis in water samples. Again, this is a soil analysis, similar way only. If water is easily soluble, if soil is easily soluble in water, you can go for soil direct dissolution, or if you're not soluble, you need to go for the digestion technique by using. Again, the similar kind of sample preparation and similar kind of standard preparation, you need to fix the linearity level based on our input, like what is the concentration of the element which is present in the sample. So you can plot the linearity and you can be able to get the result of all the samples. And when you're particularly looking for any instrument, what are the major challenges? So here I completed all the application study. So from here I will take you few information like about our Perkin-Elmer solution for metal analysis. So you know that there are 3 techniques are available. So Perkin-Elmer also having the 3 technique AA, ICPOS, ICPMS. So I will be taking you to a few slides on our feature of our instrument, what our instrument having special feature in it. So operating cost. So when you are nowadays, people are more concerned about operating cost of instrument and software, turnaround time, and the bench space for the instrument. When you come to operating cost, because these instruments require some gases, AA required acetylene, and ICP and ICPMS required argon gas. So what is the consumption of argon when you are running longer time, longer period? What is the consumption of argon? So our instrument having some unique feature where you can reduce the argon consumption ideally to run for longer time. And also when it comes to turnaround time of the instrument, our instrument comes with a lot of the feature where it required very minimum maintenance. So there will be a lot of feature associated with the instrument where you can do the do continuous run of the instrument, and also we are having very good software where it will give you flow based information like method development, sample analysis, and result printout. So all the information you will be getting from the software. And also turnaround time, when you talk about what is the runtime between the sample to sample. Suppose if you are determining 20 metals, you can able to complete the analysis within 2 minutes for the single sample. And also bench space, you can see our instrument almost very smallest in the market. And also these are the 3 different instrument technique what we are having with us. So Pinnacle series of AA, so which is comes with like either flame or furnace, or both will become on the single instrument. And again, it's a single element technique, and it's a very easy, one of the easiest technique in the market. So by anyone can do the analysis. And ICPOS, again, it's a multi-element analysis. You can able to cover the range ppb to ppm light, and also again it's a multi-element technology where it can able to determine all the metal at very low level as well as isotopic information also. ICPMS will give you like exceptional direction limit. So we are having 1000, 2000 and 5000 model in with us ICPMS. So when it comes to futures of our ICPOS, so we will be having integrated system like same instrument in AA, furnace and flame both will come. So as I said, AA required lamp. So the lamp port will be, you can see here, right? So you can use allocathode lamp, retro EDA lamp, both lamp can be used here. And 8 lamp you can put at a time. So at a time you can turn on 1 lamp and you can able to do analysis. And next lamp you can, for next analysis you can consider the another lamp. And this complete burner, everything is easily removable. So you can switch it over from furnace to flame very easily. And also furnace technique comes with the tube view camera where you can able to align your tip of your auto sampler and also you can able to address that particular thing. And also because of the design of this particular instrument, we are not using any kind of conventional lens technique. We are using fiber optics technology where you will be getting better light throughput and also minimum maintenance. So that is another feature of our AA system. So we are using solid state detector, which will give you better quantum efficiency. Here quantum efficiency is nothing but the conversion of light, the conversion of whatever light into the instrument measurement range, and that will give improved quantum efficiency. And this detector will measure the metal as well as your background simultaneously. That means it's a fast technology. And also our instrument comes with the fiber optic system where starting from the lamp up to detector, it's completely made up of the fiber design. So where you will be getting better light throughput and better light speed, and there will be very, very less maintenance on the optics format on the optical system, because it's a complete fiber system, right? So no need to remove and clean it. So most of the AA in the market, they are using photomultiplier tube. So we only using the solid state detector, so which does not require any maintenance or replacement, similar like our optic system. And when it to come to ICP OES, we are also having very salient feature in our ICP OES also. The first thing is it's a vertical design, and when you are having vertical design, the maintenance of the instrument component will be much more lesser. And also here also we are having the plasma viewing camera, where you can easily see the plasma condition, and also you can see the component, different component of the ICP part. So this simplifies your method development, and also you can able to perform the diagnostic. And also, as I said, right, RF coil is used in ICP OES, right? So here we are using flat plated aluminum coil, which significantly reduces the organ consumption. So this is a way where you can use our ICP OES with 8 liter per minute of organ flow when you compare to 50 liter per minute. So because of this flat plated technology, you can reduce the organ consumption, and this does not require any cooling, because your plasma will generate high temperature, right? So because of the design of flat plated technology, it does not take that much heat from the plasma, even though if it taken, the heat will be dissipated in the surface area. So it is a maintenance free. Because of flat plate technology, you can able to minimize the organ consumption, as well as the maintenance of the RF coil also will be minimized. So this is one of the additional advantage of our ICP OES. And second thing is the plasma shear system, right? When plasma is generated, it contains tail also. In the tail, most of the time unionized material, and because it's a very cold, right? Here only unionized material will be there. This we need to cut it, because all the ion will be generated in the middle of the plasma only, right? So we have to focus on this part only. So this can be cutted by using the shear gas. Here shear gas we are using compressed air. It's like kind of knife. It's a kind of knife. It will cut out the plasma tail by using the compressed air. So where it will be operate free from any kind of significant deposition on the component of the instrument. So because of this plasma shear and the flat plated technology, these instrument will run at very low organ gas, like starting from 8 liter per minute. And we have different kind of sample introduction system, cyclonic, which is made up of glass, and Scott, which is made up of the plastic. So based on your application, suppose if you are using very high TDS sample, the Scott will be recommended. And if you're using the normal water sample, the cyclonic spray chamber can be recommended. And also ICPOS comes with the two kind of technology, axial and radial. So axial specifically, it will measure the top of the plasma, where you can be able to measure the low concentration metal ion. Because in the plasma, if metal present at very low means, the ion will be very, very less, right? So that need to be captured directly. So that is the axial will helpful for the analysis of metal. And radial will be measured horizontally from the horizontal plasma view. It will measure the high concentration metal. So it is important to measure the metal both in axial and radial, depends on the amount of metal which is present in the sample. So this information we need to give in the instrument only. So this is software where we are entering the metal here, right? Sodium, potassium, copper and all. So this wavelength will be measured by the instrument. So this is a view how the plasma can be viewed, either radial or axial. So this will measure in the particular way. So mostly high concentration metal can be measured radially, and low concentration metal will be measured by axially. So this information we have to give to the software, like based on our experience when you are doing the sample analysis. This is our feature of our ICPMS. So ICPMS, we are having next year ICPMS, which is 3-quarter full ICPMS, because we are having 3 different quarter full to filter the masses of the ion. The first thing is what you can get from our is smart sample introduction system, and which based on the color code you can use for different kind of application. And we'll be having all matrix solution, which will dilute your sample by using argon gas only. Instead of liquid dilution, you can do here argon dilution, which will significantly decrease your matrix load into the plasma. By using the AMS, you can able to dilute the sample 200 times. Instead of liquid dilution, you can able to do argon dilution by using the all matrix solution, which is part of our ICPMS instrument. And also we are having 34 megahertz RF generator, which will give RF power to generate the plasma. And also Lumicoil, which is one of the patented technique. Unlike other ICPMS in the market, we are using very novel technology, which is maintenance free Lumicoil, which does not require any argon cooling or water cooling, and also it comes under maintenance free. And triple cone interface, which will allow your ion enter into your Mach chamber, and quadruple ion contact free quadruple ion deflector, which deflect positive charge ion without damaging your deflector part. So by using the triple cone interface and quadruple ion deflector, Perkinamar ICPMS will handle any kind of sample matrices, and it will deliver you very lower maintenance when you are using longer period. And also, as I said, ICPMS having one tool which is cell to remove the all kind of polyatomic interference, right? So that is called universal cell technology, which completely control your all kind of polyatomic interference by using KED mode, which is collision mode, and DRS mode, which is reaction mode. By using our instrument, you can able to do on-mass analysis or mass shift analysis. On-mass means the particular mass, arsenic means arsenic 75 can be determined. Mass shift means you can shift the mass of one analyte into another mass. For example, phosphorus can be shifted as a PO, phosphorus oxide. That also can be determined by the ICPMS. And also EDR technique, what we are having with our ICPMS, this help you to determine both low and high concentration in single run. Because most of the ICPMS cannot able to handle high concentration metals, but by using this extended dynamic range in our ICPMS, even you can cover any highest range, maybe 100 ppm, 1000 ppm, can be easily measured by the ICPMS. And another unique feature, dynamic bandpass tuning, which will remove all the unwanted mass in the cell during the reaction. Basically, during the reaction or collision, what are the unwanted byproduct ion can be removed from the cell. So that is one of the additional feature. And also we are the only vendor who will provide Titan microwave digestion system for the sample preparation. And now we are having our one of the instrument technique like 3 quadruple ICPMS. I think whoever using LCMS MS, they know this technology. Basically 2 mass filter will come, because there are this ICPMS comes with single quadruple or the triple quadruple. So here triple quadruple nothing but 2 quadruple analyzer will be there before the cell. So that is called the triple quadruple. But additionally, we are having the another multi quadruple instrument, which is Nexion 5000, which is having 4 stages of mass filtration. The first one is the quadruple ion deflector, which deflect your positive charge ion, and it will remove the all other unwanted ion. And first quadruple analyzer is which will control your masses of ion. Suppose you here in Nexion in multi quadruple ICPMS, you will be getting 2 mass control. So you can able to filter the which mass you want in the first quadruple, and that will be whatever the interference that can be removed by the universal cell. And third, you can filter the particular mass by using the second analyzer quadruple. So what is the advantage of this multi quadruple ICPMS means it will take you the another level of metal detection in your sample. So this is like advanced technique in the ICPMS technology. So most of the ICPMS can deal with this instrument, which is called Nexion 1000, 2000. If anyone want to go for very high technology, so we'll be having the triple quadruple ICPMS, which is the benchmark in the ICPMS technology, where you can able to do the different kind of analysis technique, where like 4 stages of mass filtration, and you'll be getting the better ion transmissions. Those will be getting from the other multi quadruple ICPMS. And another technique is the speciation. What you can do with ICPMS is, so you know, right, nowadays chromium 3, chromium 6 you need to determine, right? Chromium 3, chromium 6 is nothing but it's having different kind of oxidation state. So by determining the electronic or oxidation state or complex molecular structure is called speciation. By using HPLC, you can able to separate the different oxidation state or complex form of metal, and the separated metal can be determined by the ICPMS. So that is called a speciation technique. In this case, HPLC need to be connected with ICPMS. So where HPLC will separate your metal based on the oxidation state, and that oxidation state will be determined by the ICPMS. So here how it will give you more information, right? Suppose if you want to determine chromium in water, right? So now chromium 6 also need to be determined by in the water. So what generally we'll do in ICPMS, we directly determine the total chromium, which will give 60 ppb of chromium. But our action limit is only 50 ppb only. So this water is rejected for distribution, right, or domestic or agriculture purpose. But if you want to go for the in-depth analysis of chromium, what form of oxidative state present in that particular sample. Because chromium 3 is not, because chromium having two form of oxidative state. One is chromium 3, another one is chromium 6. So chromium 3 is non-toxic form and chromium 6 is toxic form. So when you are using this technology like HPLC coupled with ICPMS, you can able to differentiate both chromium 3 and chromium 6. So when you are using HPLC and ICPMS technology, you can able to determine both chromium 3 and chromium 6. So in this analysis, you will be getting chromium 3, which is 60 ppb, and chromium 6 is not detected, which is below detection limit. So in such case, this water can be used for the distribution. So HPLC ICPMS will give you information, right, which toxic form of element is present in your sample. Likewise, you can determine different arsenic species like arsenic 3, arsenic 5, and mercury, methyl mercury, and mercury. Similarly, chromium 3, chromium 6. So these different kind of species can be done by HPLC hyphenated with the ICPMS only. So this is a separation graph what you are getting from the HPLC ICPMS. This is a chromium 3 and chromium 6, both peak are separated, which will give you information like which form of chromium which is present in the sample. So this is a sample preparation and the regulation, because as per 10,500 and all, the chromium 6 should be less than 50 ppb, right? So by using, if you want to evaluate chromium 6 alone, the HPLC ICPMS technique will be the one of the recommended technique. So these are the concentration of different water sample which is tested, where we identified chromium 6 in all the sample. So it is which is present in almost close around maximum 0.1 ppm and minimum is less than 0.02 ppm. So that means you can able to determine very low level PPT to PPB level by using this particular analysis. So if you want additional more information can be provided on this technique, and because of time constraints, just I take you only basics of this instrument and future of the analysis technique. And these are our different model which is available in our atomic spectroscopy product line, which we are calling it as inorganic. Pinnacle series of AA, we have basically two model, 500 and 900. So both are similar only. If lab having very limited number of sample and only they want to use flame, this Pinnacle 500 will be recommended. If anybody having more number of element they want to test and they want to test PPB, PPM, then furnace and flame technique, which comes in Pinnacle 900. And AV we have two kind of technique, AV 220 and AV 550 max. And XM we have three model basically, but XM 1000, 2000 both are equivalent model. There is no major difference in XM 1000 and 2000. And XM 5000 basically we are having two quadrufold mass analyzer. So this is different from these two techniques. This is basically called as a triple quadrufold ICPMS. And by here I conclude my session. Thanks for your patience and time. And I took 10 minutes extra. As expected. I hope this session is useful for you to understand the different atomic spectroscopy available for the elemental analysis, and also hereby I will stop my presentation so we can take question whatever asked by.
Thank you,
Yeah,
sir.
actually, yeah, thank you. Yeah. Yeah, Ananta, please. Because now the questions were all answered by Suman. So all
Okay, that is
chat
great.
questions, so that way things were made easy because Suman was answering all the questions religiously. So no questions were left out. So whatever questions came in chat, it was immediately replied. So
Yeah, sir, thanks.
thank
Thank
you,
you,
Suman,
Suman.
for that. But
Thank
then
you, Suman,
one
for your
small, yeah. Then I have a small doubt, Kumaran. That is regarding like we had one experience where we were doing ICP OES analysis. I mean, it was we outsourced it, and then what we found from their result is that they have extrapolated the result. So the value they got was outside their calibration range, and but they still reported a value to us. So was that a correct procedure? They are not supposed to do that, no?
Yes, practically as the technology, they cannot do such kind of thing. They need to dilute the sample. So what will happen, suppose they are plotting linearity up to 100 ppm. So in a sample, if they are getting 1000 ppm. So what they will do, the reported value should be 1000 ppm. What they will do,
definitely.
yeah, they will dilute the sample. Suppose 10 dilution they will do, they will keep within the calibration graph. So that mostly they will be diluted, but when you are reporting, they will be giving the complete result only. So practically, they mostly get diluted.
Yeah, that is what we also expected them to do, but then they said that this is what they practice. They were, extrapolating the. I mean, the values measured itself was outside the.
Yes, sir. Yes, sir. What will
calibration
happen?
range.
Yes,
Yeah.
yeah, correct. So what will happen when it's exceeding the calibration range, and sometimes it will go to near to direction saturation range.
Yeah,
so that time we don't know how much measuring. So it is necessary, or it is whenever it's going outside the calibration range, it is important to dilute the sample to fit within the calibration range. That is a practice need to follow.
Yes. Thank you. Yeah. Okay. So I think in the chat box, Suman is still, some of you can directly ask the questions.
Okay, sir. But if the contaminants or elements in the sample is highly concentrated sample, concentration is very high, so that much dilution may cause some errors.
Yes, ma'am. Yes, ma'am. Definitely. Suppose if you are doing multiple dilution, that definitely lead you to dilution error or something. So our instrument, like when you particularly talk about ICPMS, so it is having the organ dilution instead of liquid, to avoid the liquid dilution, to minimize the error. So our instrument technique having the technology called online dilution only. It will dilute by using organ gas only. So that is what our instrument having. Again, answering your question, when you are doing multiple dilution, right? So there will be chances of error, either pipetting error or making up error, right? So we have to take utmost care during the preparation. Maybe instead of doing 10,000 dilution or 50,000 dilution, try to increase your calibration range. Suppose if you are using ICPOS, you can able to increase the calibration range up to even 1000 ppm also. Accordingly, you can dilute it. Don't go for the more dilution, which will lead to you dilution error. So accordingly, we can either by using the instrument features, whether it's having any automatic dilution technique, that is well and recommended, or when we are doing manual dilution, we need to keep the range which will not affect our results. So that is the thing we can do, ma'am, when you are doing dilution. And again, when you are doing diluting the sample, use always volumetric flask and micropipette for the dilution, and always go with the high volume dilution. Instead of 0.1 ml to 10 ml, you can take 10 ml to 100 ml like that. So in such way, you can avoid some kind of dilution error as well.
Okay.
Hope I answered your question, ma'am.
Yes.
Okay.
So Ananda, anything more like?
No, sir. Maybe you can conclude, sir. Actually.
Okay. So because I was having some network issues in between, so I thought I'll. Okay. So thank you, Kumaran and Sushant, for this very interesting session, and also Suman, who was, constantly typing for answering the questions that came in the chat box. So thank you very much for this informative session. And then, as many were asking for the PPT, so we will share the participants' mail with you. You can, you have promised to send some other reading materials also. You can send it to all our participants so that they will be benefited out of it. So thank you very much, and please convey our regards to your team at PerkinElmer. They have readily agreed to our request. So thank you all. I think Joby did not join. I was waiting for him to join, but then I was expecting him to join, but then
Sir, I think he was in our meeting, sir. Actually, yeah. I mean, Suman, sorry, he was in our meeting. I think so.
Okay. He said that he would be joining. That is.
Yes, sir.
Okay. Anyway, thank you. Yeah. Thank you, Sushant. Thank you, Kumaran, and thank you, Suman. So we are going to close the session. We again had a very eventful and wonderful day. Thank you. A very fruitful day. Thank you.
Yes, sir. Thank you.
Thank you very much. Thank you all.
Thank you, Arki sir, for this session, and thank you all the participants for your presence. Stay safe and stay healthy.
Thank you.
Thank you.
Yeah.
Bye.
So Ananda, we will close the session then.
Sir, few instructions are there for the participants.
Yeah. Please go ahead.
Yeah.
Please go ahead. Yeah.
Okay. Good evening, all. So we are here at the end of 4th day. tomorrow morning we are having 2 technical sessions. Technically, one is technical and second one is stress management. And third will be exam. Exam will be objective type. Mostly we will be trying to conduct this exam through Google platform, maybe Google Classroom or through Google Form. That we have not confirmed it. So I hope you will be familiar with Google Form and Google Spreadsheet or Google Classroom. I hope there will not be any problem soon. And we are planning to conduct it as an objective type questions. So it is not descriptive. And most of the questions will be from the materials, whatever we have shared. And of course, few percentage of the questions will be from the lecture also. Lecture in the sense, Kumar has not shared the materials. Okay, so it is not going to be equally distributed. So we have to be genuine in that particular case because we have not shared all the materials. So whatever we have shared, we will be having more questions. There is one part, and tonight we will be trying to upload the attendance for 3 days, and if possible for the 4th day also. Okay, and don't feel that your attendance has been taken completely from the poll. It seems like few people have just given the poll and they have not attended the class. So from our side, we are working hard to retrieve the entire attendance from WebEx. So thank you. With that, I conclude. Sir George, sir, anything?
No, nothing. There is one question in the chat box. What will be the number of questions and duration of test? Yeah, I think today night itself probably we'll be able to post it in their WhatsApp group, no?
Yeah. Yes.
At least those details we'll post today itself. Yeah.
Yeah. Level of questions, subjective type, it will not be very in depth. Actually, it will be broad.
Yeah, those who were attending, they'll be able to easily answer those questions. So not very difficult. We do understand things. So it will be like we'll take care of that. Okay. Okay, there is one person who is not there in the WhatsApp group. So Namita,
I will try to add you in WhatsApp group, not an issue.
And one more thing is that you should score minimum 60% marks in the exam to get the certificate.
Concluding word, the exam marks will not be shared. Right? George sir?
Yeah. It will not be shared, but you need to get at least 60% of the marks in the exam. And if you are not attending the exam also, you are not eligible for the certificate, even if you have attended all the sessions.
So it's all like we are accountable to ATAL, so that is why.
Yes.
Whatever instructions they are giving, we are just following it. Okay.
Yeah. So we will end up, sir.
We can close the session. Okay.
Yeah.
Okay.
Thank you all. Thank you very much.